Hello everyone. We are working on the part 2 of the quantitative ability section. Today we would be working on tricky questions. So let's get started. Okay, so what is with this question? Before I start reading it, let me mark 2 points over here, which is given in this question. This point is A and that point is B. So what is this question? It says, in how many ways can this guy Sam go from A to B by covering minimum distance across a grid of squares as shown in the diagram? In how many ways could he go from A to B? That is what the question is. We need to count all the ways he could have gone. Okay, so for the start, I can say he could have gone this way. This is one of the way he could have chosen to go. Okay, and another way, let me say he could have gone like this. So the question basically says you need to count all such ways. So let me focus over here for the first way I chose. Now, what was it? In the first way, can I say it like this? First, he goes like this. He has this transition. This is an upward transition, I would say, followed by again an upward transition. This was the first upward. Then it was followed by again an upward transition. Then again an upward transition, and then again an upward transition. So in this way, he took 4 upward transition, followed by, you can say, there is a horizontal, 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 5 horizontal transitions. So this was my first way he could have gone, which I happen to draw. It looked like this. He took first 4 transitions upwards, followed by 5 transitions horizontally. Now, if I just compare it with the other way I have drawn over here, in this second way, he happens to take 2 horizontal transitions for the start. This is the horizontal transition, followed again by an horizontal transition, followed by, you can say, 4 upward transitions like this. Okay, so it was followed by 4 upward transition like this. Finally, he happened to go like this, and thereby taking again those 3 horizontal transitions. So this was the first way he could have chosen, which I showed on the diagram, and this was the other way he could have chosen. Now towards the end, now if I want to generalize, I can say from going from A to B means that anyhow you need to cover 4 upward transitions and you need to cover 5 horizontal transitions. And what are the different ways? You can say this was one of the way and this was the other way. What are going to be the other ways? You just need to arrange these transitions. That is 4 upward and 5 horizontal transitions. They needed to be arranged. So basically, this question is similar to what we do, a very simple question, which we do and we call it alphabetical problem. So what we do with this alphabetical problem, let's say I have this word name Nitin, and I want to arrange the alphabets of this word Nitin. So you would say if all the alphabets were different, you would have arranged it in 5 factorial ways. But what is happening here? There are 2 N's which are repeating and 2 I's which are repeating. So you separately divide by 2 factorial and a 2 factorial. This will be how would you arrange the alphabets of the word Nitin. So coming back to this question is also basically an alphabetical question only. There are 4 U's and 5 H's. In how many ways you can arrange them? So I'll stick to the very basic way. If all were different, you would have arranged it in 9 factorial ways. But what is repeating? U is coming 4 times. So I divided by 4 factorial, and H is coming 5 times. So I separately divided by 5 factorial. And this is going to be my answer. Another interesting question, this time on speed, time, and distance. Okay, so what does it say? If you read it, it talks about there are three people, Amar, Akbar, and Anthony. They ran on a racetrack with Amar finishing 160-meter ahead of Akbar and 400-meter ahead of Anthony. Okay, at this point of time, let me draw this, you can say that this instance. Three people are running the race. I would say this is my finishing line. And what is given in this first sentence? Amar is the one who completed the race, who is on the finishing line. And when he is completing the race, he is on the finishing line. This guy is Amar. Where is Akbar? Akbar is over here. And Akbar happens to be 160-meter behind Amar at that point of time. And there is another guy called Anthony who is the slowest, and Anthony is from 400-meter from the finishing line at that point of time. Okay, so this is my first, you can say the first instance what is given over here. Now later on, what is said in the second sentence? It says Akbar finished the race 300-meter ahead of Anthony. Okay, so the first sentence talked about when Amar won the race and Akbar was coming second and Anthony was third. Now, what will happen after some point of time? Amar had already won. So at some other point of time, Akbar will also finish the race. He will be at this finishing line. And when he is at the finishing line, where is Anthony? Anthony is 300-meter behind. So these, you can say this set of information is given. And finally, what are they asking? It says they ran entire race with respective constant speed. What is the length of the racetrack? So as for the start, it seems to be a little baffling, I would say. It's a little confusing because they were mentioning, okay, this is the gaps between the racers when one of them is completing the race and when this second guy Akbar is completing the race, and finally they're asking what is going to be the length of the racetrack. But okay, let's keep it simple. What is given, we'll just move accordingly, and when we move accordingly, there would be something which we can think and we can connect it. What is going to be the length of the racetrack? Okay, so let's have a look at it over here, what we can work with. Now, if you compare with this instance to this instance, okay, you would say here Akbar is 160-meter behind the finishing line. So when Akbar finishes the race, that is, which is the instance second, Akbar would travel from this instance to this instance. Akbar, you would say distance traveled by Akbar had to be 160-meter. Now, the time in which Akbar travels this 160-meter, look at Anthony. Anthony here was 400-meter behind the finishing line. And now in the second instance, he is 300-meter behind the finishing line. So in the time Akbar travels, Akbar covers a distance of 160-meter. You would say Anthony has covered a distance of 100-meter. Initially, he was 400-meter behind the finishing line. Now he is 300-meter behind the finishing line. So if I just try to use this ratio, you would say, if you just reduce it to simple form, you say, okay, this is going to be 8:5. So the ratio of the distance covered by Akbar to the distance covered by Anthony has to be 8:5. Now, what does it mean? It means every time Akbar is covering 8 units, Anthony is going to be covering 5 units. So there is a difference of 3 units. So I'll start it like this. When the race began, anytime Akbar covers 8 units, Anthony is going to cover 5. Take an example. When Akbar covered 5, he would have covered, sorry, when Akbar covered 8, Anthony would have covered 5. When he covered 16, he would have covered 10, and so on. So this gap is widening, and this gap happens to be a gap of 3 units, which finally became a gap of 300 meters when Akbar is finishing the race. So when Akbar finishes the race, this gap of 3 unit has become a gap of 300. So this 1 unit over here is representative of 100 meters. And thereby 8 units is representative of 800 meters. And this 5 unit is representative of 500 meters. Now at this point of time, when Akbar is finishing the race, he would have traveled the entire racetrack. And when he travels the entire racetrack, there is a gap of 300 meters, which is symbolic that Akbar has traveled 800 meters. And since Akbar is completing the race, towards the end, we can correlate that the length of the racetrack is 800 meters. As in, when Akbar, let me repeat it, when Akbar finishes the race, this 8 units is representing 800. Then at that point of time, 5 units for Anthony is representing 500 meters, and thereby this gap is of 300 meters. I hope I make my point clear over here. Okay, so this time it is on permutation and combination. So what is the question says? It says how many 3-digit number less than 1000 have hundreds digit more than tens digit and tens digit more than units digit. So if I try to plan it, okay, I'll say this is a 3-digit number. And what is given? The hundreds digit is always going to be more than tens, and the tens digit is always going to be more than units digit. And I need to count all such numbers which are less than 1000. Now, since let's go step by step, since the question mentions that the hundreds digit is more than tens digit and tens digit is more than units digit, you would agree with me that repetition is not going to be allowed. Repetition is not going to be allowed, and the digits need to be selected. Mark my words, the digits need to be selected. And when we use this word select, what does it mean? We are using combination. So I happen to write 10C3. Now what does this 10C3 mean over here? I'm going to select 3 digits from 10. Okay. Now the only concern with some of us would be, okay, we have selected 3 digits. Let's take an example. I happen to select 5, 6 and 8. But at this point of time, you would think, okay, 5, 6 and 8, but how, what is going to be the mechanism? How are we going to take care of this condition that hundreds digit is more than tens and tens is more than units? Because 568 left on its own will arrange in 6 ways. But that's not our concern. Believe me, that's not our concern. The reason is there is only one way. There is only one way with the given numbers, any given numbers, where hundreds digit is going to be more than tens and tens is going to be more than units. So once you select, there is only one way which is going to be taking care of the condition. So we are not bothered about their arrangement. So my answer is 10C3 into 1, which can simply be written as 10C3. Okay, a question on profit and loss. Okay, so what does it say? There is a fruit seller and he bought 2 equal lots of oranges. Please mark the words correctly. He buys 2 equal lots of oranges. Okay, let me just show you over here. This is one lot and this is the another lot, but in quantity they are same. One at 5 for rupees 1 and another at 4 for rupees 1. So this is a little less expensive. You are getting 5 oranges for 1 rupee. And this is a little more expensive, you would say, and you're getting 4 for 1 rupee. You can just relate it like this. This is having a sticker called best quality, and thereby they are expensive and they don't have the sticker, so they are not the expensive ones, but the lot bought are equal. Okay, that the quantity bought are equal. Now towards the end he mixes them, that's what the question is saying, and he happens to sell them for 9 for rupees 2, and you need to find the profit or loss percent. Now, if I'm not paying attention to my question, I could simply answer, okay, 5 for 1 and 4 for 1 and selling 9 for 2. So there is no profit, no loss. But that's not going to be the case. Okay. So let's try to work with it. So you're buying 5 for 1 and you're buying another set 4 for 1. But they have to be bought in equal lots. And towards the end, you're selling 9 for 2. So we're going to make use of LCM over here. I would take the LCM of 5 and 4, which would have been 20, and 9, 180. So for the calculations are simple, I'll assume you're buying a lot of 180. Okay, so if you want to buy a lot of 180 of these oranges, which are 5 for 1, you would be spending 36 rupees. You're buying 5 for 1 and you need to buy 180 of them. So you would be spending 36 rupees. Now, similarly, if there is an equal lot of 180 oranges over here and you're buying 4 for 1, you would be spending how much? You would be spending 45 rupees. So the total cost incurred is going to be 81 rupees. For 81 rupees, you have bought 360 oranges, 180 of a kind and 180 of another kind. Now you're selling them by mixing. So you're selling all 360 together and you're selling it like 9 for rupees 2. So 9 for rupees 2, and you need to sell such 40 sets to make it a 360 oranges. So basically you're going to get money out of it. Selling price has to be 9 for rupees 2, 2 into 40. Such 9 sets, such one set is of 9. So 360 would be in such 40 sets, and 2 into 40 would mean you will be getting rupees 80. So the cost incurred is 81 and the money you get after selling is 80. So what is my loss? My loss has to be 1 rupee. And if I want to calculate the loss percentage, it is going to be loss over the cost, that is 81 into 100. So that is going to be my answer. Okay. Coming to another interesting question, which is based on a very simple concept, but the concept is used in a little complicated way. Okay, so let's read the question. It says for every positive even integer n, the function hn is defined to be the product of all even integers from 2 to n inclusive. So what does it mean? It says, okay, hn is going to be the product of all even integers starting from 2. So it is going to be like this till even integer n. Now, towards the end, if I read it, it says if P is the smallest prime factor of H100 plus 1, then P is. Okay. Let me make sense with H100 first. What is H100? H100 you would agree would be 2 into 4 into 6 into 8 and so on till 100. So I was okay with H100, but you can say the problem arises when he talks about P is the smallest prime factor, but he is not referring to H100, he is referring to H100 plus 1. Now, H100 plus 1, H100 on its own is going to be a very large number. And plus 1 would mean you add 1 to it, it's going to be very large. So it seems to be a little bit of a problem. How would I be able to find the smallest prime factor? But for the moment, I'll just forget this and let me focus over H100, which is more, you can say, which is more, things are more visible over here. So I'll focus on, if let's say I wanted to find smallest prime factor for H100. Now, if I want to just evaluate H100, you would say it is, once again, let me write it, 2 into 4 into 6 into 8 into, and so on. You go on and on, 96, 98, and 100. Okay. Now, if I want to simplify it a bit, I'll say, okay, I can take 2 from each term, 2 from each term outside. So there are 50 such terms. I can take 2 raised to power 50 outside. And then what is left inside? 1 into 2 into 3 into 4 and so on till 50. Please make sure of this. You have taken 2 from each term outside and thereby it accumulated a power of 50 outside. Okay. Now, if I want to work with the prime factors for H100, if I want to work with prime factors for H100, you would agree with me, 2 is a prime factor of H100. What are prime factors? Prime numbers which are factors. 3 is, if I ask you, is 3 a prime factor of H100? You would say yes, because it has a 3 in it. Next prime number would be 5. So does it have a 5? Yes, it does have a 5 in it. It's going to be a 5 somewhere over here. Then the next prime factor is going to be 7. It is going to have a 7 as well, somewhere here. Okay, somewhere it is going to be after 6, it is going to be 7 and so on. So it is going to have all prime factors till 50. Okay, all the prime factors till 50. Okay, so we made a little bit of a sense with H100. Now let's think about H100 plus 1. Now, how are H100 and H100 plus 1 related? We don't know much, but certainly we can say this is a large number, and again this is a large number which is 1 more than it. Can I say, and are they not consecutive numbers? Yes. They happen to be consecutive integers. And what do we know about consecutive integers? If the two integers are consecutive, they will not have common prime factors. Their HCF is 1. When you say consecutive integers has an HCF of 1, it means they don't have common prime factors. So whatever the prime factors of H100 were, they cannot be prime factors of H100 plus 1. Whatever prime factors of H100 were, they will not be a prime factor of H100 plus 1. So all the prime numbers till 50, I'm talking about like the prime number 47. Okay, all the prime numbers from 2 to 47 are prime factors of H100, so they cannot be prime factors of H100 plus 1. So whatever prime factor of H100 plus 1 are going to be, we cannot say exactly, we cannot pinpoint what are they going to be, but they need to be beyond 47. They have to be more than 47. Since 2 to 47 are all prime factors of H100, they cannot be prime factors of H100 plus 1. So what is the answer I'm going to mark? I'm going to mark my answer. It has to be greater than 40. Whatever the smallest prime factor is, we cannot pinpoint it, but it has to be beyond 47, and thereby we'll mark the answer as E, that is greater than 40. Okay, with this we end the part 2 of the quantitative ability section video. I hope you enjoyed the questions.